1 mole of diatomic ideal gas undergoes a cyclic process ABC as shown in figure. The process BC is adiabatic. Temperatures at A, B and C are 400 Kelvin, 800 Kelvin and 600 Kelvin respectively. Choose the correct statement. The statement goes like this: the change in internal energy in process C is 700 R. Change in internal energy in the process AB is minus 350 R. That in process BC is minus 500 R. And in the entire cyclic process it is 250 R. First of all, we have to understand the fact regarding the change in internal energy. According to the expression, we can write, suppose delta E indicates change in internal energy, then it is expressed as F by 2 mu R delta T. So this can be also written as delta E is equal to F by 2 mu R T final minus T initial of that process. The most important point regarding the change in internal energy is it does not depend on the actual process followed, but it depends only on the end path of that process. That means if we consider the change in internal energy for process AB, clearly we can see process AB is isochoric process. Process BC is given to us as adiabatic process. And process C2A, if we see, it is isobaric process. But change in internal energy is not dependent on that. Change in internal energy depends only on the end conditions in that process, that is the temperatures at the end. It does not depend on the path followed by that particular process. So this is one of the most important fact in this thing. Now if we consider the process CA, that is in the first option, then in that process C2A, final temperature is lesser than initial temperature. So obviously this term TF minus TI must be negative, but it is given that it is positive change in internal energy, so that option would be ruled out immediately. Let us consider the second option B. It is given the change in internal energy in process AB is minus 350 R. Considering process AB, where B is the final position in that process, and if we see the temperature, that temperature at position B in the process is larger than that at position A. So TF minus TI term must be positive. That gives change in internal energy of that process positive. But it is given it is negative over here. So even this option will be ruled out in this case. Let us see option C. The change in internal energy in the process BC is minus 500 R. If we see the process B to C, then final temperature is lesser, initial temperature is larger. So obviously TF minus TI term will be negative, giving delta E as negative. So in this case we can say that this is a possible option. Now if we substitute the values over here, delta E is equal to, F indicates degree of freedom. For a diatomic ideal gas, degree of freedom is 5. So 5 by 2, mu is 1 mole given to you, R is of course universal gas constant, into final temperature 600 minus initial temperature 800. So that would give us 5 by 2R into minus 200. So that would be equal to minus 500R. So we can say that option C is the correct option in this case. Let us just see regarding option D also. It is given the change in internal energy in the whole cyclic process is 250R. Actually, for any cyclic process, change in internal energy is never a value, it is always equal to 0. So this option is also ruled out, because at the end of the process, suppose the process starts from A, then at the end of cyclic process the system is once again at the same temperature. So there is no change in temperature, and hence there will be no change in internal energy at the end of cyclic process. So in our case, correct option is option C.